for some applications. You are expected to consider some essential factors such as materials requirement and physical or visual characteristics, technology capabilities like accuracy and part size. So what should be considered in 3D printing? There are large quantities of different processes for 3D printing, but each process has its specific materials and design requirements. Therefore, it's worthwhile to understand key design factors related to all 3D printing process. So what are the applications of 3D printing? Our 3D printing is commonly used in many industries for rapid prototyping and production, like aerospace and automotive, and consumer goods, special machinery, healthcare and medical, and construction industries. So maybe someone wants to know what's autonomy of a 3D printer and how to get started with 3D printing. 3D printing, 3D printing about the three-dimensional printing is a powerful technology for creating unique items with complicated geometry, serving various industries ranging from medical and automotive to defense and aerospace. What are the differences between MGF and SLS? MGF and SLS are two industry 3D printing technologies. Both of them belong to polymers powder bed fusion. The main difference between MGF and SLS is a similar heat source. We have summarized the main difference by comparing them in the fabrication process, accuracy, and the materials, costs, and leading time to help you distinguish MGF and SLS more clearly. About the CNC machining vs 3D printing. CNC machining is the most common subtractive manufacturing technology. It starts with a solid block of raw materials and utilizes various sharp routing and cutting tools to remove material. In order to achieve a required final shape with high tolerance, CNC machining is widely applied to manufacture low and medium and high value production. It provides excellent repeatability and high accuracy and various surface finishes with wide range of metal and plastics. About 3D printing or additive manufacturing produced parts by several layers of material aiding. It doesn't need any special tooling or fixtures. Its process can be divided into SLS or FDM for plastic and DMLS for metals. Perfect technology selection. There are several simple guidelines for manufacturing process decision between CNC machining and 3D printing. As we know, any parts can be produced with limited effort by subtractive. We should select CNC machining. Otherwise, 3D printing can make sense in following case. The first one is traditional ones are unable to produce, especially for high complex geometries. The second is fast turning around time is critical. The next is low cost is essential and escapably for small value less than 10. The fourth is Materials are not easier to machine, like superalloys or flexible TPU. CNC machining is able to provide higher dimensional and accuracy and better mechanical and properties in each dimensions. While in small value production, its cost will be higher. In high quality production, neither CNC machining nor 3D printing can be cost competitive operation, and traditional forming technical like investment casting, injection molding are more economic. But the process characteristics and dimension accuracy. CNC machining provides higher tolerance and excellent repeatability for different part size. In reason of cutting tools shape and internal corners have rules, while external surface can be machined at sharp edge and thin. Different 3D printing system has various dimension accuracy. All 3D printers can produce parts with good tolerance. Once you need tighter clearance, we can print oversized dimensions, then machined in post-processing operation. The minimum wall thickness of 3D printing is limited by end effector size, such as nose diameter in FDM and laser spot size in SLS. Since 3D printers parts are created layer by layer, it's visible to see layer lines in parts, especially on curved surface. But the material CNC is widely applied for metal machining. It also can be used for similar plastics and accuracies and softwares and machining. CNC machining parts have great and similar properties with fully isotropic. Common CNC materials like plastic have ABS and PEK. Metal have aluminum and stainless steel and brass. 3D printing is mainly applied for plastic. This extends for metal, and 3D printing materials are wide with different physical printers and TPU and superalloys, always manufactured with 3D printing technology. Common 3D printing materials have PLA and ABS and ASA and TPU, but metal have aluminum, stainless steel like CNC. Yeah. So the price complexity in CNC machining design, we should consider some design limitations, such as tool access and clearance, holding and moving points, and inability of square corner manufacturing. In this situation, there are some geometries cannot be proceed CNC machining, even with 5-axis CNC machines. For side filters, we need to route parts direction that addict position time and label time in process. In some cases, custom jacks and fixtures will be needed, as those items will increase the final cost. 3D printing compared to CNC machining has few geometry limitations, and the support structure are required in most technology, which will be removed in post-processing. The ability of high complex geometries production is the key structures of 3D printing. Manufacturing process in CNC machining, operators or engineers will consider tool selections, speeder, cutting path, and part position. At first, all those factors will impact final parts quality and processing time greatly. This manufacturing process is labor intensive. In reason of all set up are manual. After machining process, those components are ready for post-operations. In 3D printing, operator only need to prepare digital file with orientation and addict support, then send it to printing machines, which require little human intervention. Once printing finished, we have manual cleaning and post-processing. There are various post-processing modes for CNC machining and 3D printing parts. In order to improve parts functionality and aesthetics, most common post-processing technology, including CNC machining and bead blasting, anodizing, and powder coating, like 3D printing, have medium blasting, sanding, and polish, and so on. So technology selection experience. We need to following the rule to selection the right technology for your parts production. CNC machining is most suitable for medium to high value production, about 1 to 500. So with simple geometries, 3D printing is best for low quality and complex geometries. For metal parts, it's best for low quality and complex geometries. For metal parts, CNC machining is more competitive with geometry's limitation. Once quality is more than 500 parts, other farming technologies are more suitable. So, advantages of 3D printing. We have 3D printing confers great benefits for making a prototype of the product, especially in the manufacturing field. It creates infinite possibility for the manufacturing of small batches. One offers and functional prototyping in increasing productivity and efficiency, while saving time and money. Each 3D printing process has its specific benefits as well as its limitations compared with other processes. 3D printing is an advanced manufacturing technology for complex parts. It can create parts layer by layer at one time. This must have various advantages over traditional manufacturing techniques like CNC machining and injection molding or die casting. Although 3D printing is unable to replace traditional methods, there are many applications 3D printing can provide quick production with high accuracy from functional materials like speed. 3D printing has an addictive manufacturing mode has one main advantages of speed. It can produce complex parts in hours from a CAD file. This is advantageous is the rapid verification and development of design ideas. As in past, It will take days or weeks to get a prototype. Additive manufacturing can deliver a raw model for designer within hours. But 3D printers will take longer time to print parts. The ability of functional end part production at low or medium value will offer time saving comparing to traditional manufacturing techniques. As injection molding leading time is at last weeks. One-step manufacturing. The biggest concern for every designer is how to produce a part in most effective way. In traditional manufacturing techniques, there are a large number of steps to follow. Those steps order affect the final quality and manufacturability of the design. For customer steel bracket, traditional manufacturing months will start with a CD model. Once design is converted, steel materials will be cut into suitable size profile, then clamp those profiles into position and weld them form the bracket one by one. Polish welds to a good surface finish, drilling hole on suitable position. Finally, the bracket is sandblasted and printed and painted for better appearance. While additive manufacturing machines can finish this in just one step, there is no interaction forming operators in manufacturing process. Once the design is finished, we just need to upload it to the machine and print it in one step for a few hours. It can reduce the dependence to different production months and provide greater control of final products. About the cost, manufacturing cost can be divided into three categories and machine operation cost, material cost, and labor cost. 3D printing has low value production is significant competitive comparing traditional manufacturing months. Is cheaper than other alternative months for prototypes production with form and fitness verification, such as injection molding. As value increase, traditional techniques become more and more cost-effective, and the high setup costs are justified by their value production. About the 3D printing technology will consume amount of engineering to produce one single part, but for complex geometries parts, it will give rise to higher efficiency and turnaround. In this process, machine operation cost has lost contribution to the overall cost. The material cost varies significantly for different 3D printing technologies. The material for additive manufacturing is difficult to make a qualifying comparison with traditional ones. Material cost is the main contribution to part production cost. But the labor cost, 3D printing has the lowest labor cost in manufacturing process, except post-operation, and operator's major work is pricing a bottle on 3D printer. Then the machine will follow an automotive process to finish part production. Comparing to traditional months, the high-skilled machinists and operators are required. The labor cost for 3D printing is nearly zero. About 3D printing, the design, 3D printing has nearly no restriction. Once compared to traditional manufacturing process, as components are produced layer by layer, design requirements like draft angle and undercut and tool access are not applied in 3D printing design. Although there are some restrictions on the minimum size feature, most of the limitations are how to optimize printing or rotation, reduce port dependency, and film like code. Those will increase design freedom and enable complex geometries creations. 3D printing allows not only more design freedom, but also complete customers' design as correct 3D printing also produced a single part at one time. It's the most suitable way for one-off production. The concept is widely applied in medical and dental areas, such as customer prosthetic and implants and the dental as additive manufacturing allows cost-effective single production of customer parts. 3D printing will only use suitable value of materials to produce a part. In most processes, raw materials can be recycled and reused in next production, so there is very little materials waste. While subtractive manufacturing months such as CNC milling or turning will remove amount of materials from raw blockers. Those result to high value of material waste. And the 3D printing will have good choice for risk mitigation. A fault prototype will cost the designer time and money. A small change in models or fabrication months will impact final cost significantly. 3D printing can produce prototypes before expensive investment equipment such as models, and in order to verify the design and imitate the risk, building confidence before large mass production. Metal parts are always produced by investment casting technology. However, there is an issue of molding cost. In order to produce large metal parts with very low cost, so we apply FDM technology to create castable partners, which cannot be created by traditional manufacturing techniques with various features. In this process, over alternative technologies like DMLS or CNC. In low-value metal parts production, investment casting and CNC machining and DMLS are all viable technologies. We summarize the advantages of each manufacturing month as following. It's critical to notice that final parts geometries and determine which month is the most suitable way. So this is a general guidelines for design making. About the MLS, is a powder bed fusion technology. It's widely applied to produce metal parts with high determinal accuracy. This technology is able to create parts with very complex geometries design. Its design freedom encourages it to be adopted by many industries like automotive and aerospace. Work-weight optimization and excellent performance are critical. The MLS can produce parts from a wide range of metals, like aluminum and stainless steel, as well as metal in testing and medical industries like aluminum. The main limitations of DMLS are the high cost and medical industries and small build size and low lead time. DMLS parts also need support structures to reduce the likelihood of distortion and warping, and must be removed after printing. Like investment casting apply wax patterns to create model for casting. It has clearly brought out without any residues like 3D printing pattern and model assembly and cut off and finished parts. Yeah, so the this is today and to share some information for you, and the next will my partner Lucy to explain it to you. So welcome, Lucy. Hello everyone, this is Lucy. Welcome to my live stream. Today, I will introduce the scope of some current process in manufacturing industry about injection mold. Injection molding. Injection molding is a manufacturing process for producing parts by injection molten material into a mold. Injection molding can be performed with a host of materials, many including metals, for which the process is called die casting, glasses, elastomers, confections, and most commonly ceramic plastic and thermostatic polymers. Material for the part is fed into a heated barrel mixed using a helical screw and injected into a mold cavity, where it cools and hardens to the configuration of the cavity. After a product is designed, usually by an industrial designer or an engineer, molds are made by a mold maker or tool maker from metal, usually either steel or aluminum, and precision machined to form the features of the designed part. Injection molding a variety of parts, from the smallest components to entire body panels of cars. Advances in 3D printing technology. Advancing in 3D printing technology using photopolymers that don't melt during the injection molding of some lower temperature Some thermoplastics can be used for some simple injection molds. Injection molding uses a special purpose machine that has three parts. The injection unit, the mold, and the clamp. Parts to be injection molded must be very carefully designed to facilitate to the molding process. The material used for the part, the design, shape, and features of the part, the material of the mold, and the property of the molding machine must all be taken into account. The versatility of injection molding is facilitated by this breadth of design considerations and the possibilities. Applications. Injection molding is used to create many things such as vials, spoons, pickings, bottle caps, automotive parts and components, toys, popcorns, some musical instrument and parts of them, one piece chairs and small tables, storage containers, mechanical parts including jars and most other plastic products available today. Injection molding is the most common modern method of manufacturing plastic parts. It is ideal for producing high volume of same object. For forming hollow plastic parts. It's also used for forming glass bottles or other hollow shapes. In general, there are three main types of blow molding: extrusion blow molding, injection blow molding, and injection stretch blow molding. The blow molding process begins with softer plastic by heating a preform or parison. The parison is a tube-like pieces of plastic with a hole in one end through which compressed air can enter. The plastic workpieces is then clamped into a mold and air is blown into it. The air pressure inflates the plastic which conforms to the mold. Once the plastic has cooled and hardened, the mold opens and the part is injected. Water channels within the mold assist cooling. Like we usually see bottles, buckets, cans, bins, and all containers that take food, beverages, cosmetics, medicines, and daily necessities, all of them produced by blow molding. What's the difference between blow molding and injection molding? Injection molding and blow molding are both high production volume manufacturing techniques that form plastic into many different shapes and sizes. Injection molding is used for complex solid components, whereas blow molding is used for thin wall hollow parts. Injection molding forces plastic into a mold under high pressure. Blow molding, on the other hand, expand a hollow tube or plastic into a mold using compressed air. Blow molding is generally cheaper than injection molding. This is because blow molded products are less complex and therefore the required tooling is cheaper. In addition, injection molding requires heavy-duty hydraulic rams to inject the plastic material and to keep the mold from leaking plastic during the injection phase. Blow molding can produce a single components hollow containers which would be impossible to make with injection molding. Blow molding is less expensive than injection molding. Blow molding is Blow molding is less expensive than injection molding. Blow molding is performed at a lower pressure than injection molding, allowing the use of less expensive tooling and equipment. Blow molding is only applicable to thin wall hollow parts. That being the case, it is limited to such applications. It can be used for sheet wall products. The parasol needs to be trimmed off at the top and of the bottom of the part after blow molding. Injection molding typically requires no post-processing. In summer, blow molding is more cheaper, but if you need paint or good surface finish, it will be cost a lot because the surface is rough. But the surface of injection mold is very smooth. We can do finish directly. The third is sheet metal. Sheet metal manufacturing is the process of creating sheet metal parts by cutting, bending, and forming thin metal sheets into specific shape and size. The process typically uses cutting, bending, and assembly techniques. Sheet metal is made from various materials, including steel, aluminum, zinc, and copper. It can be as thin as a few thousandths of an inch or as thick as several millimeters. Sheet metal parts are used in cars, buildings, airplanes, and other applications. The manufacturing process starts with selecting metal and cutting it into the desired size and shape. The metal is then transformed into its final product through various techniques such as rolling, extruding, and bending. The end product can vary from simple flat panels to complex three-dimensional structures. Following the techniques outlined below, the metal fabrication process works effectively and produce top quality results. Manufacturers can use a variety of machines for cutting sheet metal, including those special designed for fabrication work. Laser cutting is one of the most common methods of sheet metal cutting. A laser cutter uses a laser amplified by a lens or mirror to cut through thin to medium sheet metal but difficult into the most challenging materials. Water cutting is a technique that uses high-pressure water to slice through metal. The water jet is especially used for cutting lower melting metal since it doesn't hit the metal enough to deform it. Plasma cutting creates a channel of ionized gas that can easily be cut through. Sheet metal plasma cutters are less precise than laser or water jet cutters, but they are fast, efficient, and have low setup cost. The above three cutting machines can be used for sheet metal and other materials, but different methods are also available for sheet metal fabrication. For example, punch uses a punch and die to create precise holes in sheet metal. The sheet metal is placed between the two pieces, one of which has a hollow at its center. When the punch hits the metal, it pushes the hollow through to meet the other die's hollow. The result is a punctured load of removing material that can be used as new blanking. If multiple holes are designed, the same equipment type can be used to make them. Sheet metal deforming process involves changing the process and machine sheet metal without cutting it. Bending is one of the most critical forming process, and it can be done using a brake machine. A sheet metal company can use this tool to bend sheet metal into UV and channels up to 120 degrees. Thinner sheet metals are easier to tan. This is because they are less rigid and have great flexibility. And the reverse is also possible. Metal fabricators can remove horizontal straight bands in sheet metal by straighten the metal by removing small portions at regular intervals. The stamping process is another deformation process, but can also be considered separate subcategory. A hydraulic and mechanical puncture process with a tool and die is used to deform sheet metal in the stamping process. The process is similar to punch but does not remove material necessary. Sheet metal stamping can be used for specific tasks such as drawing, hemming, and more. The spin sheet metal fabrication process uses lasers to press the metal against rotating tools. The process is similar to CNC or pottery spin and helps make road parts like cylinders, corners, and more. In addition to bending, other methods of shaping metal include rolling, which is used to create complex bands in sheet metal, and rolling where sheet metal is fed between a pair of rollers to reduce thickness. Some processes combine cutting and forming. For example, the sheet metal expansion process involves cutting several metal slots and then expanding the metal. What are the advantages of sheet metal forming? Sheet metal forming has a number of advantages and benefits. Here are some advantages of sheet metal forming. Relatively inexpensive when compared to other manufacturing processes, such as casting or forging. Very flexible in terms of design and application. Sheet metal can be formed in various ways with a wide variety of metals in order to produce a wide range of parts. Metal parts are extremely durable with good tensile strength and environmental resistance, suitable for producing small batteries, which makes it ideal for rapid prototyping. The use of sheet metal makes sheet metal parts lightweight while still remaining durable. This is ideal for application in which a high strength to weight ratio is required. What are the disadvantages of sheet metal forming? Sheet metal forming does have some drawbacks. Here are some disadvantages of sheet metal forming. To start manufacturing with sheet metal forming, a high initial investment is required to acquire the necessary equipment and tooling. Very complex designs can be unsuitable for sheet metal forming and result in higher cost and production times. Sheet metal forming is a very labor-intensive process with many manual steps. This can make it slower than other processes such as stamping. Which industries typically use the sheet metal forming? Sheet metal forming is used in an incredible wide range of industries. Since two is versatility, relatively low cost, and the durability of the produced parts. Some industries that commonly use sheet metal forming are aerospace uses sheet metal forming due to the general precision of the forming process, along with the high strength to weight ratio of the produced parts. Is commonly used for fuselages and structural components in aircraft and spacecraft. Automotive use sheet metal forming for body panels, chassis components, and other structural parts of the vehicles. The durable, lightweight components produced by sheet metal forming make the mast an ideal choice. Construction makes use of sheet metal forming to produce durable, weather-resistant components such as the roofing sheets, structural components, and ductwork. Medical equipment, housing and enclosure for medical equipment, as well as medical devices, are commonly made by sheet metal forming due to its ability to meet strict standards and requirements. Household applications. Sheet metal forming is commonly used for making enclosures, framers, and other structural components used in household applications due to its versatility, pressure, and durability. Modern products manufacturing requires process and techniques that ensure precision and accuracy due to the increasing complexity of product design. Consequently, there is a rush for development and innovation in manufacturing techniques, especially the introduction of automation. Next time I will introduce CNC molding and 3D printing process, and introduce its basic mean and application disadvantage and disadvantages. By the way, About the injection molding. Injection molding can be an expense. How can I reduce injection molding cost? Injection molding can be an expensive process, but we have several ways we can reduce mold cost, including eliminate undercuts, remove unnecessary features, use a core cavity approach, reduce cosmetic finish, design parts that self-made, modify and reuse existing molds, monitor DFM and size, use a multi-cavity or family type of mold. Consider your part size. Injection molding is also not ideal for producing large parts as a single pieces. This is because of the size limitations of injection molding machines and the mold tools. Items that are too large for injection molding machines capability need to be created as multiple parts and joined together later. Okay, thanks for your time. See you next time. Bye.